So hey everyone, welcome back to my channel. This is Lakshay here. So today we're gonna start with our lead code question number 61, which says rotate list. So what this question says, it says given the head of a linked list, rotate the list to the right by k places. It means that we will be given the head of a list and a variable value k, and we have to rotate the list according to the value of k to the right side. Means the rightmost element will stick to the first, then another rightmost will again go to the first, like this. Okay, as you can see here, value k equals to 2, then on first rotation our 5 is going and getting attached to first, like here. Then on second rotation our 4 is going and getting attached at the first position, like here. And this is our final list. So let's see how we can approach this problem by taking this example only. 1 2 3 4 5, and here is null. So first of all we will check some conditions, that if if is k equals to 0, or head equals to null, or heads next is equals to null, then we will simply return our head, because it means that we are not having enough values to rotate our list. That's why we will simply return our head. But if not the case, then what we will do, then we know that our head is currently here, then we will create a pointer current, which will be currently at head, and a variable length, which will be at starting 1. Now we will first calculate the length of our linked list with the help of this variable and this pointer. So how we can do that? We will keep on traversing till our currents next will be not equals to null, like this. At first iteration current moves here and our length increases, then current moves here, then our length increases, then current moves here, then here. Now we can see current next is equals to null, so we will break down from here and we will get our length equals to 5, and we know our k is equals to 2. Okay, so now what we will do, first of all we will now make our linked list to a circular linked list. Okay, so how we can do that? We know our current is currently here, so we will simply point currents next to our head, like this. So our linked list will be looking something like this. Okay, cool. Now what we will do, now we will modify our k like this. Means our k will become k percent modulo length. Why we do this? We do this if our k value is greater than our length of list. For example, our k value is 6 here and our length we know is 5. So it means that it is same as if our value is 1. They both will give the same result. That's why we do perform this operation, because it will give our value like this, 1 only. That's why we perform this to minimize our number of iterations. Okay, so this case here it looks like this. It will give same as 2, and we will also modify our k length minus k, which will be 5 minus 2 equals to 3. So now our length is same, but now our k is equals to 3. Okay, so now what we will do, let's again create a list 3 4 5, and this points to here and header. Now what we will do, now we will create another pointer, that is temp, and we will put it here, and we will keep on iterating till our k is not equals to 1. Means till our k reaches 1, and at each iteration our temp will move to next step and our k reduces 1, means k minus minus. Let's see, on first iteration our temp moves here and our k reduces to 2. On second, temp reaches here and our k moves to 1. But now we can see that our k is now equals to 1, so we will break from here, means we will not traverse further. So what we will do, now we'll simply place our head to temps next, means here temp next will be head, and our temp next will becomes equals to null. Okay, great, and we will simply return our head. So this will be our linked list look like. final list 1, 2 and 3 and this null. Hence this is what our linked list look like, and we have also see here in the answer also it looks something like this. So that's it. This is how we approach this problem. Let's write down its pseudocode. Okay, so first of all the base case, that if our k is equals to 0 or our head is equals to null or our head next is equals to null, we will simply return our head. Okay, that's it. But if not the case, we will create a new pointer current and place to head and a length variable which will be currently at 1, and now we will calculate a length while current next is not equals to null. We will keep on traversing like this. Current equals to current dot next and a length will plus plus. After this we will get a length of a list, and we will also make it circular like this. Current next will point to head. Okay, now we will modify our k and k value, that is k dot k modulo our length, and then again our k equals to length minus k like this. Okay, cool. Now what we will do, now we will finally modify our list like this. We will first of all create a temporary variable, means a pointer, and place it at head. Okay, now we will keep on iterating till our k becomes 1, means while our k is not equals to 1, we will keep on sending temp equals to temp dot next and k becomes minus minus like this. Great. After this what we will do, we will simply, because now we will get our pointers on the desired location that we want, and we will simply point our head equals to temp dot next on temp next, and our temp next will become null. At last we will return our final head. So that's it. This is our pseudocode, which is kind of easy only. You must try it yourself, and at last I will also provide the final code that you can directly paste on your LeetCode. So here is your code, which we have already discussed earlier. That first of all our condition. After that, if it falls, then we will first calculate the length of our list. Then we will make it circular and modify our value of k. Then we will finally find the location till where we have to rotate, and at last we will rotate our list and return our head. Cool. Now let's discuss the time complexity. So the time complexity will be big of n, and how it is that? It is because it takes big of n for the loop to find the length and big of n for the loop to reach rotation point. Means the way we are rotating our list, that's why it kind of big of n plus b of n, which becomes big of 2n, but here constant value is negligible, so we get big of n, and that's why like this only our space complexity is big of 1, because it is working on constant space. So that's it. Here is our problem, here is a solution. So thanks for watching. Bye bye, see you in next video.